Okay, this is lesson 73, adding and subtracting decimal numbers. So here's the whole lesson. Line up your decimals. We're done. That's it. No, not really. But seriously, that's the whole lesson. So example 1 says, find the perimeter of this triangle. So they gave you 3 dimensions, 4.3, 7.6, and 12.5. So, did you notice how I already had those decimals there? And I already have a decimal for my answer? So the trick is to make sure that you get your columns right, just like we do when we're, oops, that one should kind of be over there. Let's give ourselves a little white out for that. There. Okay, so once I have everything lined up, I can just add them up. My decimal's already down here. So 9 plus 5 is 14, carry the 1, 5, 12, 13, 14, carry the 1. So my answer is 24.4, 24 and 4/10. And those were in centimeters, and I need to make sure when I'm measuring something I label it. So it is 24.4 centimeters. Got it? Okay. Example 2. They've got a ladder, and it's not quite tall enough. So the roof is 6 3/700 meters above the ground. The ladder could only reach 4 2/10 meters. So they want to know how much higher was the roof than the ladder. So I set my problem up, and I'm going to say 6 3/700. Remember, my decimals are lined up, so my 4 is going to go here, my 2 is going to go there, but I don't have anything in the hundredths place. So remember our lesson where we can add a 0? So I can add that 0, and now I can just subtract. 7 minus 0 is 7, 3 minus 2 is 1, 6 minus 4 is 2. So my ladder is 2 1700 meters shorter than the roof. It's not tall enough. So got to get a bigger ladder, huh? Okay. Example 3 says from the beginning of the trail to the Hoji camp is 3 4/45 miles. From Hoji camp to the summit is another 6.7 miles. How far is it from the beginning of the trail to the summit? So on those kind of problems where it gives you different dimensions and you kind of have to think about what they're telling you, I like to draw a little map, and my map is simple enough just to be a line. I thought about drawing a mountain, but there's no need. So the start to Hoji camp is 3 4/45. From Hoji camp to the top of the mountain, the summit is 6 7/10 miles. So they want you to know how far is it from here to here, from start to the summit. So I can just add those, can't I? Okay, I didn't set up my decimals this time, but I'm going to remember to line my decimals up. So my 6 goes here, my 7 goes there, right? And I'm going to add them. I can add a 0. I can just add them up. Okay, so I find that it is 10 1500 miles from start to finish, from the bottom to the top. Am I finished here? Not yet, because this is in miles. You can either write out miles or MI. If you just do M, it's meters. Okay, so that was pretty simple. I didn't put my dots, my decimals in ahead of time, but I made sure they lined up, okay? And I make sure to keep everything in nice, neat columns. I am not by nature a neat writer, but it's really important to keep your columns lined up when you're doing this. Write big, write neat. Do as I say, and do as I try to do. Not always the best at it. Okay, example 4. This one's complicated. So it says a garden snail moves a distance of 14.63 feet, or 14 6300 feet, and moves at a rate of about 2 feet every 1 minute. The snail has already moved 8.71 feet, or 8 and 71/100 feet. Estimate the length of time it will take the snail to move the remainder of the distance. So I know I'm going to estimate round something. What are they asking me to find? Let's read that question again. Estimate the length of time. Okay, so I definitely need that. It will take the snail to move the remainder of the distance. So I'm going to have to find that too. I got to find two things, right? So I got to find out how far it is. So the snail started here, he moved to here, and he's got to get up to here. So how far is that? And then how long will it take him to go that far? Okay, so I've got 8 and 14. If I use compatible numbers, I can say that that's 8.63 and this is 14.63. Did them backwards. I should have done it this way. I find that it's 6 feet, right? Now, I tend to round to the nearest whatever. In this case, I would round to the nearest ones place instead of using compatible numbers. Let's try that. So 8.71, it's going to round to 9. 14.63 is going to round to 15. So what's 15 minus 9? 6. So I'm going to get the same answer here. You can do it either way. When you can use compatible numbers, a lot of times that'll give you a better estimate. In this case, it was the same. Okay, so we know that he has to go right here about 6 feet. So what was our rate? How far did we say that snail moved? If he goes 2 feet in 1 minute, I know he's got to go 6 feet, right? So there's 1 minute, 1 minute, 1 minute. Oh, so it's going to take him 3 more minutes, right? To move that 6 feet. So every 2 feet takes him a minute. He's got to go 6 feet. That took a lot of work, didn't it? That took me a whole page to do. Now, I know I spread my work out a little bit. You guys be sure to show your work. I will buy you more paper if you need it, but spread your work out. Don't try to cram it up in a little box that's that size, okay? All right, good luck on this stuff.